So friends, come to another question, that is integrations of e to the power x dx divided by square root of e to the power x plus of 8. So to solve this numerical, first of all, we will assume e to the power x plus of 8 as v square. Okay. So let e to the power x plus of 8 is equal to v square. Now differentiating both sides with respect to x, we will get d dx of e to the power x plus of 8 is e to the power x is equal to 2v into dv by dx. As at the numerator e to the power x into dx present, so we can write e to the power x dx is equal to 2v dv. Okay. Now come to the integrations. So what is the integration? I is equal to integrations of, instead of e to the power x dx, we will write 2v dv. So 2v dv at the numerator, and at the denominator square root of e to the power x plus of 8 can be written as v, as we assume e to the power x plus of 8 is equal to v square. So v square square root, that is v. So definitely this is 2 into v, and v will be cancelled from both numerator and denominator. So this is simply 2 into integrations of dv. So what is I? Implies that I is equal to 2 into integrations of dv is v. So this is 2v plus of c, where c is the integration constant. Now to get the final answers, we have to reput the value of v as square root of e to the power x plus of 8. So integration become 2 into root over e to the power x plus of 1 plus of c. Okay. So this is the answer. Now come to the next question. Now come to the another question, that is integrations of e to the power x dx divided by 1 plus of e to the power 2x. To solve this numerical, we will first assume e to the power x is equal to v at the denominator. Okay. So let e to the power x is equal to v. Now differentiating both sides with respect to x. So d dx of e to the power x is e to the power x is equal to dv by dx. Okay. Now as the numerator of the integrations is e to the power x dx, so we can write e to the power x dx is equal to dv. Okay. Now what is the integration? The integration become I is equal to integrations of, instead of this e to the power x dx at the numerator, we can directly written as dv, and the denominator 1 plus of e to the power 2x, that is 1 plus of v square. So this is 1 plus of v square. Now it is the standard form of the integrations of dx divided by 1 plus of x square, that is tan inverse of x. So integrations of dv divided by 1 plus of v square, that will be tan inverse of v plus of c, where c is the integration constant. So we can write I is equal to tan inverse of v plus of c, where c is the integration constant. Now to get the final answer, we have to put the original value of v, which is e to the power x. So therefore I is equal to tan inverse of e to the power x plus of c. So this is the answer. Okay. Clear? Now come to the next question. So friends, come to the another question, that is integrations of e to the power x into 1 plus e to the power x whole square dx. It is very easy question. To solve this numerical, first of all, we will assume this 1 plus e to the power x as v. Okay. So let 1 plus e to the power x is equal to v. Now differentiating both sides with respect to x. So d dx of 1 plus of e to the power x is e to the power x. This is equal to dv by dx. Now at the integration, e to the power x into dx is present. So that is why we are writing e to the power x into dx is equal to dv. Okay. Now come to the integration. So what is the integrations become? Instead of this e to the power x into dx, we will directly write dv. So I is equal to integrations of, here dv present, and 1 plus e to the power x whole square can be written as v square. So the integration become integrations of v square dv, and it is v cube by 3 plus of c. So I is equal to v cube by 3 plus of c. Now to get the final answers, put the value of v as 1 plus of e to the power x. So what is the final answer? I is equal to 1 upon 3 1 plus e to the power x whole cube plus of c. This is the answer. Clear? Now come to the next question. So friends, let's come to another question, that is integrations of 1 minus of 1 by x square into e to the power x plus of 1 by x dx. Okay. Now to solve this numerical, we will assume x plus of 1 by x as v. Okay. So let's start. X plus of 1 by x is equal to v. Now differentiating both sides with respect to x. So d dx of x plus of 1 by x is 1 minus of 1 by x square. So we are writing 1 minus of 1 by x square is equal to dv by dx. As at the integration 1 minus of 1 by x square dx is present. So that is why we can write 1 minus of 1 by x square into dx is equal to dv. Okay. Now come to the integrations. So the integration become I is equal to integrations of, instead of this 1 minus of 1 by x square dx, we can write directly as dv. So this is e to the power x plus 1 by x is v. So e to the power v and 1 minus of 1 by x square dx as dv. So we are writing this is as dv. Okay. So the integrations become integrations of e to the power v dv, and integrations of e to the power v dv is e to the power v plus of c, where c is the integration constant. So I is equal to e to the power v plus of c. Now to get the final answer, we have to substitute v by x plus of 1 by x. So what is the integration? I is equal to e to the power x plus of 1 by x plus of c. So this is the answer. Clear? Now come to the next question. So friends, come to another question, that is integrations of e to the power x into 1 plus x whole divided by cos square x e to the power x dx. Okay. Now to solve this type of numerical, we will first assume x into e to the power x by a new variable, that is v. So let x into e to the power x is equal to v. Now differentiating both sides with respect to x. So d dx of x into e to the power x is equal to dv by dx. Okay. Now what is the derivative of x into e to the power x? Applying the product rule, we will get this is as e to the power x into x plus 1. This is equal to dv by dx. Clear? Now at the numerator of the integration, we have e to the power x into 1 plus x into dx. So if we make the cross multiplication by dx, we will get e to the power x into x plus 1 into dx as dv. Okay. Now what is the integration become? The integration become, instead of e to the power x into 1 plus x dx, we will write dv. So writing dv whole divided by cos square v. X into e to the power x is v, so cos square v. So we are writing this is as cos square v. Okay. Now this can be written as I equal to sec square v dv, and integrations of sec square v dv is the standard formula, that is tan v plus of c. So we are writing here I is equal to tan of v plus of c, where c is the integration constant. Now for the final results, we will reput the value of v by x into e to the power x. So what will be the integration? I is equal to tan of x into e to the power x plus of c. So this is the final answer. Clear? Okay. Now come to the next question. So friends, let's come to the another question, that is integrations of e to the power x sec x into 1 plus of tan x. In this case, we will apply the formula integrations of e to the power x fx plus f dash x dx is equal to e to the power x fx plus of c. Okay. So, first of all we have to arrange, we can write I is equal to integrations of e to the power x sec x into 1, that is sec x plus sec x into tan x. So, inside the bracket we will write this is sec x plus sec x into tan of x dx. Okay. Now we know the derivative of sec x is sec x into tan x. So, if we assume sec x as fx, so this part sec x into tan x will be f dash x. Okay. So, let f of x is equal to sec of x. This gives f dash x is equal to sec x into tan of x. Now, the integration become I is equal to integrations of e to the power x. Instead of sec x we are writing fx. So, this is fx plus instead of sec x into tan x we are writing f dash x. So, we are writing f dash x and dx is there. Okay. So, the formula e to the power x into fx plus f dash x dx is e to the power x into fx. So, the integration is e to the power x into fx plus of c, where c is the integration constant. Now, to put the final answer, we have to substitute fx by sec x again. So, I is equal to e to the power x into sec of x plus of c. This is the final answer. Okay, clear? Now, come to the next question. So, friends, come to the next question, that is integrations of e to the power x into log of sec x plus tan x plus of sec x dx. Okay. Here also we will apply the formula e to the power x into fx plus of f dash x dx is equal to e to the power x fx plus of c. So, first of all we will assume log of sec x plus of tan x as fx, as the derivative of log of sec x plus of tan x is nothing but sec of x. Okay. So, just assuming fx is equal to log of sec of x plus tan of x. Okay. Now, differentiating both sides with respect to x. So, d dx of fx, this is nothing but f dash x, is equal to d dx of log of sec of x plus tan of x. Okay. Now, d dx of log of sec x plus tan x can be found by applications of chain rule. So, d dx of log of sec x plus tan x is 1 divided by sec of x plus tan of x into d dx of sec x plus of tan x. Is it clear? And we can proceed, d dx of sec x plus tan x is sec x tan x plus of sec square x. So, in the next step, 1 divided by sec x plus tan x into d dx of sec x is sec x tan x. So, we are writing here sec x into tan of x plus d dx of tan of x is sec square x. So, this is sec square x. So, we get f dash x as 1 by sec x plus of tan x into sec x tan x plus of sec square x. Now, if we take common sec x from this bracket, we will get tan x plus sec x, and here sec x plus tan x present, which will be cancelled out. Okay. So, finally, we can write f dash x as sec of x. Okay. Now, so what is the integrations become? The integrations become I is equal to what? Integrations of e to the power x, instead of log of sec x plus tan x we will write fx, and this sec x as f dash x. Okay. So, I equal to integrations of e to the power x fx plus of f dash x dx. Okay. Clear? Now, what is the formula of e to the power x into fx plus of f dash x dx? This is e to the power x into fx plus of c, where c is the integration constant. So, writing I is equal to e to the power x into fx plus of c. This is the integrations. Now, to get the final results, we have to reput fx as log of sec x plus of tan x. So writing I is equal to e to the power x log of sec of x plus tan of x plus of c. So this is the answer. Okay, clear? Now come to the next question. So friends, come to the another question, that is integrations of e to the power x into 1 plus of x square whole divided by 1 plus of x whole square dx. Okay. Now to solve this numericals, we will first split into two integration. Just look. I is e to the power x into this 1 plus of x square can be written as 1 plus of x whole square minus of 2x, and at the denominator 1 plus of x whole square there, so we write as same into dx. Okay, clear? Now we can written as I is equal to integrations of e to the power x, this 1 plus x whole square by 1 plus of x whole square as 1 minus of 2x by 1 plus of x whole square dx. Okay, now splitting into two integrations. So I is equal to integrations of e to the power x into 1, that is e to the power x dx, minus of integrations of e to the power x into x divided by 1 plus x whole square dx. Okay, and put these two outside of these integrations. Clear? Now in the next step, I is equal to integrations of e to the power x dx. We know it is e to the power x plus of c. So we are writing this is as e to the power x plus of c. So this part completed. And in this integration, we can write x by 1 plus x whole square as it is x plus of 1 minus of 1 divided by x plus of 1 whole square dx. Okay, clear? So I is equal to e to the power x plus of c minus of 2 into integrations of x plus 1 divided by x plus 1 whole square, that is 1 divided by x plus 1 minus of 1 divided by x plus 1 whole square. So we are writing this is as e to the power x into x plus 1 by 1 plus x whole square, that is 1 divided by x plus of 1 minus of 1 divided by x plus of 1 whole square. So this is 1 divided by x plus 1 whole square. Okay, this into dx. Is it clear? Now in this integration, if we assume 1 divided by x plus 1 as fx, then we know f dash x will be minus of 1 divided by x plus 1 whole square. So in this integrations, we can apply the formula e to the power x into fx plus of f dash x dx is equal to e to the power x into fx plus of c. Okay, clear? So let's move. Let fx is equal to 1 divided by x plus 1 in the second integration. In the second integration. Okay, clear? So obviously differentiating both sides with respect to x, will get f dash x is equal to d dx of 1 divided by x plus 1, that will be minus of 1 divided by x plus 1 whole square. So what will be the integration? This implies integrations become, it is e to the power x plus of c, so we will write here e to the power x plus of c. So e to the power x plus of c minus 2 into integrations of e to the power x into fx plus of f dash x, because minus of 1 divided by x plus 1 whole square will be f dash x. So e to the power x into fx plus of f dash x dx. Okay, clear? So I become e to the power x plus of c minus of 2 e to the power x into fx plus of c dash. Okay, clear? So fx is here 1 divided by x plus 1. So to put the final answer, we can write I is equal to e to the power x plus of c minus 2 into e to the power x, and instead of fx we will write 1 divided by x plus of 1. So this is 1 divided by x plus of 1 plus of c dash. Now c and c dash, both of these are constant. So combining these two constant we will get a new constant considered as lambda. So the final answer will be I equal to e to the power x minus 2 into e to the power x into 1 divided by x plus 1 plus of lambda, where lambda is nothing but c plus of c dash. Now if we can simplify this also after taking common e to the power x. So if we take common e to the power x, we will get it is e to the power x into x minus of 1 divided by x plus of 1 plus of lambda. Okay, clear? So this is the final answer. Now come to the next question. So friends, see the example. Integrations of dx divided by x square into square root of 1 minus of x square. Now to solve this type of numerical where square root of 1 minus x square is there, in that case we can assume x is equal to sine theta. Okay, so first of all let x is equal to sine of theta. Now differentiating both sides with respect to x. So d dx of x is 1. So 1 is equal to d dx of sine of theta. Okay. So 1 can be written as d dx of sine theta is cos theta into d theta by dx. So we are writing this is cos of theta into d theta divided by d of x. So what is dx? Dx is cos of theta into d theta. Okay. Now come to the integrations. Now the integrations can be written as, instead of dx we can write cos theta d theta. So this is cos theta d theta at the numerator, and at the denominator instead of x square we can write this is sine square theta. So we are writing sine square theta into square root of 1 minus of x square, that is 1 minus of sine square theta. So 1 minus of sine square theta. Now the whole integrations become in terms of theta. Okay. Now let's simplify it. So I is integrations of cos of theta d theta divided by sine square theta into square root of 1 minus sine square theta can be written as cos of theta. So this is cos of theta. So obviously cos theta are cancelled. So this become 1 by sine square theta d theta, which can be written as cosec square theta d theta. So I can be written as integration of cosec square theta d theta. Okay, clear? So this is cosec square theta d theta. Now integrations of cosec square theta d theta is just the standard formula, that is equal to minus of cot theta plus of c. So we can write I is equal to minus of cot of theta plus of c, where c is the integration constant. Is it clear? Now we have to convert this cot theta in terms of x. As we have sin theta is x, so cos theta is square root of 1 minus of x square. So what will be the cot theta? It is square root of 1 minus x square by x. So I can be written as minus of square root of 1 minus x square divided by x plus of c. So this is the answer. Clear? Okay. Now come to the next example. So friends, come to the another example, that is integrations of dx divided by 1 plus of x square into square root of 1 plus of x square. We can solve this numerical in the two ways. What? Look, first method is just take common x square from this first factor and take common x square from inside the square root. So what happens? Integrations of dx divided by x cube into 1 by x square plus of 1 into square root of 1 by x square plus of 1. Okay. Now if we assume 1 by x square plus of 1 as v, so the derivative of 1 by x square plus of 1 become minus of 2 divided by x cube, and look, 1 divided by x cube is already present in the integration. Okay. So let 1 divided by x square plus of 1 as v. So, assuming v is equal to 1 by x square plus of 1. Now, differentiating both sides with respect to x. So, we will get dv by dx as minus of 2 divided by x cube. Okay, clear? So, we can write dv by minus of 2 is equal to dx divided by x cube. Okay, clear? Now, come to the integration. So, what is the integration become? I is equal to integrations of, instead of this dx divided by x cube, we can write minus of dv by 2. So, instead of dx divided by x cube, just we are substituting minus of dv by 2. Okay? And at the denominator, 1 by x square plus 1 into square root of 1 by x square plus 1 presents. That can be written as v into square root of v, that is v to the power 3 by 2. So, into v to the power 3 by 2. Is it clear? So, the whole integration, that is integrations of dx divided by 1 plus of x square into square root of 1 plus of x square, converted in the form of integrations of minus dv by 2 into v to the power 3 by 2, where v is equal to 1 by x square plus of 1. So, what is the integration? I is equal to minus of half into integrations of v to the power minus 3 by 2 dv. Now, this is quite easy. We can apply directly the formula integrations of x to the power m dx. So, applying the formula, we will get I is equal to minus of half into v to the power minus 3 by 2 plus 1, that is minus of, divided by minus of half plus of c, where c is the integration constant. So, simplifying, we get I is equal to, just we can cancel minus half from numerator and denominator. So, this will be v to the power minus half, that is nothing but 1 divided by square root of v plus of c. Okay, clear? Now, to get the final answer, we have to substitute v by 1 by x square plus of 1. So, substituting here, we get I is equal to 1 divided by square root of 1 by x square plus of 1 plus of c. Now, simplifying further, it is, what we will get? We will get I is equal to, if we simplify this, we will get x divided by square root of 1 plus of x square plus of c. Clear? Now, come to the second method for these integrations. Let's look.